Okay, this is the Module 3 test review. Answer key. Start with question number 1. It says Dale has a special deck of cards. Each card has a different rational number on it. The cards are 0.25, 4 fifths, 2 ninths, 0.48, and 8 elevenths. How many cards have a value that is greater than 1/2? So I'll show my work on my whiteboard here. Basically, the way that I would think about this one would be on one side, I could have 1/2, and on the other side, I could have all these numbers. And what I'm trying to do is find numbers that have a value greater than 1/2. I could convert them to decimals. I know that 1/2 has a decimal value of 0.5, and the first one, 0.25. 0.25 is less than 0.50, so that doesn't work. The second one, 4 fifths. 4 fifths equals 0.8. 0.8 is greater than 0.5, so that is greater than 1/2. Let's say I put 2 ninths in right here. Now I don't know the decimal equivalent of 2 over 9, but I do know that it's less than half. If I give you a quiz and you got 2 out of 9, that's definitely less than 50%. So that's less than a half. 0.48, that's actually really close to 0.50, but it's less, so that one doesn't count. The last one is 8 elevenths. 8 out of 11. Again, I don't know the decimal equivalent of 8 out of 11, but I do know it's more than half. If you took a quiz and got 8 points out of 11, that's more than a 50%. So that would be actually greater than a half. So that's the second one I circled. How many did I circle? 2 cards. Alrighty. Let's move on. Question number 2. Which set of rational numbers is correctly ordered from least to greatest? So it's kind of a lot to look at, but let's think about negatives. This is the key here. If I draw a number line, even if I don't have anything on there, I need to know that 0 would theoretically be in the middle, and on the left would be, we could just do -1 right here, and on the right would be +1. Just remember on a number line that the farther left you go, the less it is. These are the negatives and these are the positives. So if you think about that, look at the options here. Let's just choose a couple options. Let's just compare like A and D. A looks like they go in order from -0.48, -0.47, -0.46. Let's look down at D. D is exactly the opposite, -0.45, -0.46. So when it comes to negatives, which one's going to be farther past 0? If I go back to my number line and start at 0, right in the middle would be -0.50. Well, 2 to the right of that would be -0.48. And then to the right of that would be -0.47. Well, the one that's farthest to the left is -0.48. Then -0.47. The answer to question number 2 is A. Now, while I've got these questions on this page, I'm going to skip ahead to number 4. Okay. 4 says, Kendra placed the numbers -3/8, 0.27, -3/10, and 4/7 on the number line. Which of the numbers is furthest from 0? So we're actually not looking for a negative answer. We're not looking for a positive answer. We're looking for the greatest absolute value. There are definitely different ways to do this. It's not a bad idea to eliminate bad answers. Let's just look at the decimals. And let's not even worry about the fact that it's -0.3. Let's just compare the absolute value of 0.3 and 0.27. Which one of those is further from 0? Well, 30 is a bigger number than 27. So 0.27 is one of our worst answers there. So based on that, the other 3 options could be in play. We've got 0.30. We've got 3/8, and we've done 3/8 recently. We know that 3/8 is actually equal to 0.375. And if we compare that to 0.30, that's actually greater, so that eliminates 0.330. Now I've got 4/7. And again, we're not looking for the positive or the negative. We're looking for its distance from 0. And without converting that into a decimal, let's think about that real quick. I know it's kind of weird to only take an 8-question quiz or a 7-question quiz, but if you took a quiz in science and got 3 out of 8, and you took a quiz in math and got 4 out of 7, while neither score is really very good, which one is a little better? Well, 4/7 is a little bit better. 4/7 is actually greater than a half. If you think about it, 4 is more than half of 7, so 4/7 is greater than half, and 3/8 is under half. So that, without even doing a conversion, logic tells you that 4/7 is the greatest absolute value. Let's go ahead and do number 5, and then we'll move on to the bottom of the page. Mandy divided a 12-pound bag of oranges into 5 equal piles. That looks like this. 12 pounds of oranges divided by 5 equals. And the directions don't actually ask you to do 12 divided by 5. It asks you to write 12 divided by 5 as a rational number. Well, we've gone over this quite a few times. The dividend becomes your numerator. The divisor becomes your denominator. And the answer is 12 over 5, which it doesn't look like that is one of the options. But if you examine them closely, 12 over 5 does appear. 5 goes into 12 2 whole times with 2 left over. 2 2/5. The correct answer is D. All right, continuing on the bottom of the front side, we're on question number 3 now. Question number 3 says, which number line shows the correct placement of the points in the table? And the points in the table are negative 31 hundredths, negative 33 hundredths, negative 38 hundredths, and negative 29 hundredths. So if you look at all those options, you'll see they all have some things in common. Probably the best strategy on something like this is to just look at the first number line, A, and see if it works. For example, maybe I'll use a highlighter. For example, A is supposed to be at negative 31 hundredths. A right here, that looks like it could be negative 31 hundredths. Right next to it is 0.3 or 0.30, so just to the left would be negative 31 hundredths. B is supposed to be at negative 33 hundredths. That seems like that would work. C is supposed to be at negative 38. That's almost up to negative 0.4, so that makes sense. And D is supposed to be at negative 29. Now, whenever you look at the first answer and you think, wow, that seems like it should be the right answer, it is a good idea to go through the rest of them and see if maybe some of those don't make sense. Like, for example, if you look at B, I'm going to move this up. If you look at B, B doesn't work because according to number line B, C is past negative 40, so C would have to be at something like negative 41 hundredths, which is not true. If you look at C, C doesn't work because A is supposed to be at negative 31 hundredths, and it's way out here. That's not negative 31 hundredths, so it's not C, it's not B. And then D, there's a reason why D doesn't work. D doesn't work because C is supposed to be at negative 38 hundredths, and B is supposed to be at negative 33 hundredths, so B can't be past C. So it's a good idea to find what you think is the right answer, and then just double check that by seeing if you can find mistakes in the other ones. All right, let's go ahead and check out 6 and 7. Question 6 states, which statement about rational numbers is not correct? So here's the deal. If we're looking for a statement that is not correct, that means that some of the statements are correct. So it's not a bad idea to go through and just read them and determine if they're true or false. So the first statement, all rational numbers are also integers. If you remember back to the Venn diagram that we had, the Venn diagram was the center circle was whole numbers, and the middle circle was integers, and the last circle was rational numbers. And this statement right here says all rational numbers are also integers. Well, I can think of a rational number like 4/7. That is not an integer. So I don't think A is true, so I'm going to write an F there for false. But I will go through the rest of these. 0 is a rational number. Well, 0 is a whole number, and anything that's a whole number would also be inside the integer circle and also inside the rational number circle. So B is actually true. I'm going to put a T there for true. C says all integers are also rational numbers. So integers are things like -7 or +7. Both of those numbers are inside the rational number circle. That is true. And D, all rational numbers can be written in the form of A over B. That's the definition of a rational number. Anything that can be written as a fraction where B is not equal to 0 is a rational number, so that is true. So if B, C, and D are true, then A is the only false statement, so the correct answer to number 6 is A. Alright, last one for the front page. Question 7 reads, Philip wrote the numbers 3 and 1/5, 3 and 1/7, 5 and 1/8, and 1 and 5/6 in the form of a over b. What is the greatest numerator that Philip wrote? The key to these directions right here is in the form of a over b. And what we learned in lesson 3.1, in the form of a over b, that just means as a fraction. So for example, 3 and 1/5 written as a fraction. Some kids say that's a fraction, but that's actually a mixed number. 3 and 1/5 written as a fraction is 3 times 5 is 15, plus 1 is 16. It's 16 over 5. So that's one of the numerators is 16. We've also got 3 and 1/7 written in the form of a over b as 3 times 7 is 21, plus 1 is 22, 22 sevenths. We've also got 5 and 1/8 is going to be 5 times 8 is 40, plus 1 is 41, 41 over 8. And the last one is 1 and 5/6. That's going to be 1 times 6 is 6, plus 5 is 11, 11 over 6. Reread the question. What is the greatest numerator that Philip wrote? The numerators are 16, 22, 41, or 11. Clearly the greatest numerator there is D, 41.